Hello and welcome everyone. So this video is going to be following Chapter 8 in the OpenStax Principles of Microeconomics text. This chapter has to do with perfect competition. Now, if you haven't got the OpenStax text yet and you would like to, you can just go to openstax.org, go under Subjects, go to Business. You can find Economics here, and you can find the macroeconomics text. The economics one has macro and micro together. The one that we're following here is the Principles of Microeconomics. You can click Get the Book. I would recommend downloading a PDF because then you'll have page numbers. You could just click to view online. And if you do that, it's good because it'll display, nicely. Maybe if you have a tablet or something. The problem is it won't have page numbers. It is searchable, so that's good. Or you could follow along with my free Substack book. This is at microeconomicprinciples.substack.com. And you can find my chapter on perfect competition. That's the one that's relevant for today. You have to scroll down. I forget exactly which one it is. But anyway, you can do that, and you can find the chapter to read along there as well. Anyway, so what we're going to cover in this lecture, kind of going along with the outline from the slides, is perfect competition, why it's relevant, why it matters, how perfectly competitive firms make output decisions, entry and exit in the long run, and then efficiency in perfectly competitive markets. Right, so the first thing keep in mind is that there are really no legitimately perfectly competitive markets. That's important to say at the outset. Sometimes you might be asked to come up with examples of perfect competition. And there's a lot of industries that are fairly close. There's things where you could say, for all practical purposes, it's close to perfect competition. Sometimes, such as what they're suggesting here, you might think of farming, you might think of agricultural commodities as a perfectly competitive market. It's not bad, it's close. I would say if you had a large farmer's market, that'd be a lot closer to a perfectly competitive market. And the reason why, well, I'll discuss as I go over these examples. Perfect competition is a market structure. Market structure refers to, well, what's the composition, what's the rivalry, number of sellers, how easy it is to exit or enter a market, and so on and so forth. And so typically with market structure, we're thinking of perfect competition, monopoly, monopolistic competition, and then oligopoly as our four kind of quintessential market structures. Perfect competition is the first one. Even though I just said that there's no such thing as a perfectly competitive market, it's a really important benchmark. We'll get to that at kind of the end of the slide deck here in terms of thinking about economic efficiency. And actually, these are the criteria that we have for perfect competition. If you evaluate any market where there's some reasonable level of competition, you can look and see what assumption fails to hold and what's the departure from perfect competition. What's the consequence of, for instance, not having identical products? So that's really interesting. So that's part of the purpose of studying perfect competition. All right, so here's the four criteria. Sometimes we list these as separate, but what they've listed here is there are four kind of assumptions for perfect competition are we've got many firms producing identical products. So there's no product differentiation. This we have to be really strict about. So this is maybe the main reason why there's actually no perfectly competitive markets, because in the real world there's product differentiation. So when it says identical products, this means literally the exact same thing being sold from everyone. That's why agriculture and commodities are not like a bad example, because it gets identical products correct. We have many buyers and many sellers. Sometimes that fails, right? So even my farmer's market example, it has to be a large farmer's market to be able to say there's arguably many sellers, right? So you need many buyers and many sellers. All the buyers and sellers have all the relevant information to make rational decisions, and firms can enter and leave the market without restrictions. So exiting the market without restrictions is really important too. Obviously entry, because it's barriers to entry that'll protect market power for our monopoly or firms with market power in the future. We'll discuss that in actually the next chapter. Being able to leave the market without restrictions, that's important as well. There's some industries where it's actually really difficult to get out of them. An example would be like a gas station, right? So gas station's got this fuel tank that's under the ground. There's environmental considerations. You can't just not have it. You can't just resell the gas station without decommissioning that tank, because you have to worry if is it going to leak or whatever. There's this large process, maybe pulling the tank out of the ground. Same thing with a nuclear power plant. So there's a big process of decommissioning a nuclear power plant, and there's many nuclear power plants that are being operated far beyond their intended lifespan. And one of the reasons why, well, we need the electricity from them. But another one is that sometimes it can be cheaper to keep operating than it is to shut the thing down, because there's a really large fixed cost of leaving the market to decommission the power plant. Anyway, so beyond these, this gives rise to the important assumption or consequence of the buyers and sellers being price takers. So we say a firm in a perfectly competitive market must take the prevailing market price as given. Actually, buyers as well. So the idea is that no buyer is able to influence the market price. No seller is able to influence the market price. Beyond all of these, now this isn't one that anybody ever teaches, and so it wouldn't show up anywhere else. But I think beyond saying these four criteria, 5 counting the price-taking assumption, it is important also to say that for a perfectly competitive market, there'd be low to zero transaction cost or search cost for customers. Meaning, not only are there many buyers and buyers and sellers have full information, and they're all selling identical products, but the buyers and sellers can easily find each other, right? So if there were many buyers and many sellers in a particular industry, but they're all scattered across like the metro area, right? That's not perfect competition, because even, think of the market for gasoline, for gas stations. They're all selling gasoline, but a gas station that's on one side of town doesn't really have to worry about competition from the gas station on the other side of town, because people would waste so much time and gas going to that other station. Whereas gas stations that are literally across the street from each other or nearby, you'll see much more correlated prices, because there's low to zero transaction costs for customers picking one or the other, right? So that's the last kind of thing I think is important, just conceptually understanding what's going on with perfect competition, or with a level of competition that approaches perfect competition, is that it's easy for customers to be able to find or buy from a rival that is selling at a different price. That's one of the reasons why e-commerce and online retailing has restored competition in a lot of markets, because it lowers the search cost tremendously to be able to match buyers and sellers, especially for price-conscious buyers trying to find a better deal. Okay, so how perfectly competitive firms make output decisions. Importantly, a firm in a perfectly competitive market is going to focus only on its output decision. Officially, what it's going to do is it's going to adjust its level of production to bring its marginal cost equal to the price. As we'll go through here, sometimes we'll say the competitive market is going to set price equal to marginal cost and then produce whatever is the according output. No, us as the analyst or as the student solving a problem is going to look for the place where price is equal to marginal cost. But we just said the competitive market doesn't allow a firm to adjust the price. So it's not setting price equal to marginal cost, it's setting its marginal cost equal to the price. Okay, so perfectly competitive firm has only one major decision to make: what quantity to produce. Perfectly competitive firm must accept the price for its output as determined by the product's market demand and supply. Yeah, so the market demand and market supply, composed of all the buyers and all the sellers in the market, are going to adjust to the equilibrium price that firms are then going to take as given, and they react to that price. The maximum profit will occur at the quantity where the difference between total revenue and total cost is the largest. Well, yeah, that's true by definition. This isn't anything unique to perfect competition. This is actually not a super helpful line here. Maximum profit is where total revenue and difference between total revenue and total cost is the largest. Of course that's true, because profit is defined as total revenue minus total cost. So I don't know what they're doing there. Well, whatever. So total cost and total revenue at a raspberry farm. Right. Total revenue for a perfectly competitive firm is a straight line sloping up. The slope is equal to the price of the good. Yeah, so here's total revenue. Total revenue in a constant price industry is going to be upward sloping. So that's true here. Total revenue I'm going to see if I can kind of adjust this and say the reason why it's an upward sloping line. Here we have we have total revenue on the vertical, we have quantity on the horizontal. So we have total revenue as a function of quantity. Total revenue, I'm just going to say, is equal to price times quantity. That's just the definition of total revenue, price times quantity. Well, if price is constant, sorry, I know it's loud if I type on this. If price is constant, then then this has a upward. This is upward sloping line, right? So you could think of prices being like, this is like total revenue if the market price is like 2. So, slope of the line is 2, positive 2 if the price is 2, right? So we're just thinking of a situation where if we have a constant price, we just have a constant slope for this line. Importantly, that's very different from a situation where you have a monopoly. If you have a monopoly, or if you're looking for the total revenue possible along the demand curve, it's going to be U-shaped opening downward. And so that's important later in the next lecture. Anyway, so total cost also slopes up, but with some curvature. Well, right, we're assuming there's maybe increasing cost due to diminishing marginal product, and so total cost will rise. We get not quite a U-shape for total cost. For average total cost, we'd certainly get a U-shaped. And then sure, the gap between total revenue and total cost, where that's maximized, that's going to be the profit maximizing quantity. So at higher levels of output, total cost begins to slope upward more steeply because diminishing marginal returns, diminishing marginal product. Maximal profit will occur at the quantity where the difference between total revenue and total cost is the largest. Yeah, right. Marginal revenue is the additional revenue gained from selling one more unit. It's the incremental change in total revenue. The way that we'd actually see marginal revenue, sorry, I know like my microphone is literally next to my keyboard, so I know this is probably a little bit annoying, but marginal revenue is going to be change in total revenue divided by change in output. So it's like total revenue 2 minus total revenue 1 divided by Q2 minus Q1. And if you know calculus, then this is like just literally the derivative of total revenue with respect to quantity, DTR, DQ. Right? So that's like, or DTR, DQ. Fine. Marginal cost is the cost per additional unit sold. So it's the change in total cost when you sell one more unit. I'm going to make this like not as loud. So this is change in total cost divided by change in output. So it'd be like this. Marginal cost is the first derivative of total cost if you know calculus. If not, it's just like the change in total cost divided by the change in output. So if you have 2 total costs, 2 output, like you have like a columns or rows in a table, you just subtract one row from the other row and then divide it by the change in output. Oftentimes this change is like 1, right? Although if you had a table, you have to pay attention because sometimes we give a table that increments in something other than 1. So anyway, that's why it's important to look at the definition or like the mathematical definition of marginal revenue and marginal cost in case you ever have to calculate that from a table or something. Profit maximizing choice for a perfectly competitive firm occurs at the level of output where marginal revenue equals marginal cost. That's right. Yeah. So that's the rule actually is like across all market structures, perfect competition, monopoly, honestly even oligopoly and monopolistic competition, the profit maximizing level of output is going to occur where marginal revenue equals marginal cost. And the thing that makes perfect competition different is because price is always constant, price is always equal to marginal revenue. So for perfect competition, maybe let me just expand this. So for perfect competition, price equals marginal revenue, and then that equals marginal cost. For monopoly, price is going to be greater than marginal revenue, which will be equal to marginal cost. We'll see that in the next lecture. But anyway, the reason for perfect competition, why price equals marginal revenue, is remember, marginal revenue is the change in revenue as you produce one more unit, as you sell one more unit. But every unit you're selling is going to fetch exactly the market price because you're taking the price as given. So then marginal revenue, the contribution marginal revenue is making to total revenue is always the market price. Okay, so price equals marginal revenue, and that's going to equal marginal cost at the profit maximizing level of output. For a competitive firm, actually, we say its marginal revenue curve and its demand curve are horizontal. It's the same as the market price. Okay, so marginal revenues and marginal cost at the raspberry farm. So here's our raspberry farm. Here's our market demand. Here's our supply. There's the market price. There's the market quantity. The equilibrium price of raspberries is determined through the interaction of market supply and demand. Okay, that's happening at $4. We're getting a quantity of 800. If there's 10 firms in the market, the equilibrium quantity is going to be 800. So the idea is like, here's the market equilibrium quantity. We just said hypothetically there's 10 firms, so each of them is going to produce 80. That's assuming that all the firms are going to be the same scale and everything, but all right, fine. So for a perfectly competitive firm, the marginal revenue curve is a horizontal line because it's equal to the price of the good, in this case $4, determined by the market. That's why I said, like, we think of, for a perfectly competitive firm, its marginal revenue curve being horizontal at the market price, which we said was 4. Also, this is the demand curve for a perfectly competitive firm. We'll find where that crosses marginal cost. Here it happens at 80. So that's the profit maximizing point. And the idea is, so what I say is going on is the firm is choosing how much output to make. And when it's doing that, what it's observing is how its costs are changing. So you could think of like the farmer's looking at its internal spreadsheets about what happens at different output levels, and it's estimating and extrapolating what's going to happen. It sees, okay, if we produce 20, here's our marginal cost, 40, here's our marginal cost, 60, here it is, 80 or 100 or whatever. And it realizes what the price is, and it says, oh, look, if we produce a quantity of 80, our marginal cost of the 80th unit is going to be $4, which matches the market price. Good. That's exactly what we'll produce. Right? So that's kind of how the process works. The firm's going to set it. It's going to adjust its output. And as it adjusts its output, it moves to a different point on the marginal cost curve. And it wants to stop right at the point where the marginal cost associated with that level of output is $4. Because in this example, $4 was the market price. Okay, so the marginal cost curve is sometimes initially downward sloping if there's a region of increasing marginal returns at low levels of output. So the marginal cost curve can slope down, then it slopes up. Okay, so here's a real world example of like why the marginal cost curve could initially slope down and then go up. You can imagine like a landscaping business, right? So you have like a truck and then a lawnmower, and they drive to a neighborhood and they mow lawns, right? And then maybe they mow some neighbors' lawns or whatever. And the idea is, okay, there's a really large fixed cost associated with operating this landscaping business in the first place, because they've got to hire they've got the worker, and the number of labor hours they hire, that'll be a variable cost. The fixed cost is the truck, the trailer, and the lawnmower equipment, and so on and so forth. And as they go to mow like the first lawn, they also have to incur the transportation cost of moving to that neighborhood, like getting to the neighborhood or whatever, unloading the trailer, getting the lawnmower set up, and then, actually mowing. And so there's a cost associated with that, a marginal cost associated with that first lawn. But if they're able to mow the next door neighbor lawn or across the street or something, they don't have to pack up their trailer and move anywhere. Right? They can just like run across the street. And so the marginal cost of the second house is going to be way lower than the first house, because they don't have to drive to the neighborhood to do that additional house, right? To go one more house, they just go across the street. Maybe they mow the neighbor's yard next to that one. And so it's even a little bit lower because the marginal cost, they're just like running across like contiguous grass or something like that. But at a certain point, they do have to move the trailer. They have to load the mower back up, and then they have to go down the street or go to the next neighborhood, and then marginal cost starts rising. Right? So that's a story of why you could that's a story of an industry where you might see initially decreasing marginal cost and then eventually increasing marginal cost. Okay, so it is eventually upward sloping at high levels of output as diminishing marginal returns kick in. Right? All right. So profits and losses with the average cost curve. Does maximizing profit, so producing where marginal revenue equals marginal cost, imply an actual economic profit? The answer depends on the relationship between price and average total cost, which is the average profit margin, average profit or profit margin. Right. So here's the important concept. The firm is going to want to, if it is going to produce the quantity where marginal revenue equals marginal cost. That's true across all market structures. But just because we find a level of output, such as this one right here, where marginal revenue equals marginal cost, doesn't mean we immediately know that we want to produce. So if this firm is going to produce anything, if this raspberry farm is going to produce anything, it's going to produce 80, right? 80 packs of raspberries. But it has to pay attention to where its average cost is relative to these $4. If its average costs are way higher, like if the average total cost curve is way up here, this firm would actually rather shut down and not produce anything. It'll exit the industry, right? If the average costs are lower, if the average cost of producing these 80 units somehow swoops down below Well, it wouldn't swoop below, but anyway. So suppose it swooped down. So we had a situation um, uh, where the price equals marginal cost at a point that is above average total cost. Then there'd be positive economic profits, and the firm would want to produce. That's the key idea. Okay, so we'll go through it in the slides. Maybe that'll work all right. So here's price and average cost at a raspberry farm. So in panel A, the price intersects marginal cost above the average cost curve. Since price is greater than average cost, the firm's making a profit. Oh, actually, I should say this. The way that I recommend writing out profit is with the following formula. So profit is obviously total revenue minus total cost. But what I like to use is profit equals price minus average total cost times quantity, which is algebraically equivalent. But I like writing it this way because price minus average total cost, this is the price. Average total cost is going to be down here. And then price minus average cost over the quantity is going to be an area, right? So price minus average total cost is the vertical distance. Quantity is on the horizontal, so this gives us the area of a box, right? Here, price equals average total cost, so that's going to be a 0 times whatever is the quantity, so there's no profit. And then here, price is going to be below average total cost, so it'll actually be negative. It'll be price minus something bigger than that price. In this case, it's like 2 minus like 2.75 or something. So this is negative economic profit. But I like encouraging using this formula because now you can see, oh, sure, this is like a length and this is a width, and then you got a clear profit box. Okay, fine. So in panel B, price intersects marginal cost at the minimum point of the average cost curve. Here the firm's breaking even. This means there's 0 economic profits. And then in panel C, the price intersects marginal cost below the average cost curve. So since price is lower than average cost, the firm is making a loss. If it's making a loss, now we've got a further decision to make, which is, do we want to shut down or do we want to keep operating and then eventually exit? Shut down is a short-run decision. Exit is a long-run decision. The firm would shut down if price is also below average variable cost. The firm would continue to produce, in this case, those 65 units, if the price is bigger than average variable cost but less than average total cost, but then that firm's going to exit in the long run. Okay, so more on that and what's to follow. All right, so discussion question. Why can a firm not avoid losses by shutting down and not producing at all? All right, so, well, think of my landscaping example. The firm has already got the truck and the mower, and if it turns out that what a homeowner is going to pay for somebody to mow its lawn is below like the wages of the workers, then you're not going to want to produce. However, because you're getting for each lawn that you're mowing less than what you have to pay the workers, that's really bad. But you also can't avoid the fact that you've already got this truck, and so you're going to incur the fixed cost, right? Or in the example of the raspberry farm, if it turns out the price of raspberries has fallen, you probably already have the raspberry farm. You plant those many seasons in advance, and so now you've got a whole field or orchard full of raspberries. And what are you going to do with them? Well, maybe it doesn't pay to harvest them, but you can't avoid the cost of like having the land and having those berries in the first place. So why can a firm not avoid losses by shutting down and not producing at all? Well, because of the presence of fixed costs, which in the short run are going to be a sunk cost. What's the shutdown point? So the shutdown point is the intersection of average variable cost and the marginal cost curve. So if price is below minimum average variable cost, the firm shuts down. If price is greater than minimum average variable cost, the firm stays in business. And in particular, this is corresponding to the place where the price equals marginal cost. So this should really say if price equals marginal cost, let me just make that change. If price equals marginal cost at a point that's below minimum average cost, or if price equals marginal cost at a point that's above minimum average cost, then the firm stays in business. All right, so here's the shutdown point for our raspberry farm. We've got our average cost right here. We've got our average variable cost, and then here we've got our average cost, and here we've got our average variable cost. The difference between these is that this price is going to lie right in between. It's going to cross marginal cost at a point right in between average cost and average variable cost, right? But down here, this is going to be the market price. It's going to go actually everywhere below average variable cost. So this is going to be a situation where the firm's definitely going to shut down. This is a situation where the firm's going to operate in the short run and then exit in the long run. Here's the steps of the problem though. So like firstly, we try to find what would be the optimal output if we're going to produce. So in this case, we'll compare the market price to the marginal cost. And I think we said this is like 65 or something. Yeah, it's level of 65. Okay, so here the firm would say if we do operate, it's going to be 65. And then, okay, what's the price at 65 versus the average variable cost at 65? Well, price is higher than average variable cost, so we'll produce in the short run. But notice that price at 65 is lower than our average total cost at 65, so we'll exit in the long run. So that's this right here. In panel A, the firm produces a level of 65. It's making losses, but price is bigger than average variable cost, so it continues to operate, at least in the short run. What about this panel here? Now, price is going to cross marginal cost right here. I guess they're calling it 60. So this is at a situation where the price is lower than average variable cost. So this firm's going to shut down kind of immediately. It's not even going to operate. And so if it were to produce, it would produce a quantity of 60, but it sees actually we lose less if we just stop producing and just only incur our fixed cost, right? This is exactly the situation where like the price that somebody is willing to pay you to mow their lawn is less than how much you have to pay your worker to do it, right? Or if the price of raspberries in this example is like the market price of raspberries is lower than the price that it would cost you to harvest the raspberries, right? Firm can't pay workers, it has to shut down. All right, so here's short run outcomes for a perfectly competitive firm. We divide the marginal cost curve into 3 zones based on where it crosses average cost and average variable cost. We call the point where marginal cost crosses average cost the break-even point. This is where there's zero economic profit. This is actually the minimum of average cost, because by definition, marginal cost crosses average cost from below at the minimum. This is also the minimum of average variable cost, because by definition, marginal cost crosses average variable cost from below at its minimum. One way to think about that, we said this in like the cost lecture, but think about like batting average. If you think of your batting average for a particular game, be it like baseball or softball, as the marginal contribution, and batting average over the entire season as the average, the contribution of a given game will bring up the average if it's higher than your season average, right? Everywhere the marginal cost is above average variable cost, it's going to bring up average cost. And then if your season average is if your game average is below the season average, anytime you have a bad game, it's going to bring down the average. And so anyway, that's what's going on there. If price equals break-even point, the firm's making zero economic profits. If the firm is operating at a price greater than the break-even point, the firm's earning profits, and you can think of the box that we'd get. So if the price is up here, you'd calculate, here would be where price crosses marginal cost. Here's average cost, and you calculate this box if you're using the formula that I suggested, or a negative box if you're getting a situation where price is greater than or is less than average cost. All right, break-even point, the level of output where marginal cost crosses average cost curve at the minimum of average cost. If the price is at this point, the firm's earning zero economic profit. Yeah. All right, so we kind of said that already. All right, so the shutdown point. So here's the shutdown point. This is at the minimum of average variable cost. If the shutdown point is less than the price, which is less than the break-even point, the firm's making losses, but continues to operate in the short run because it's covering its variable costs and more if the price is above the shutdown price. All right, whatever. So let me explain this differently. If the price is crossing marginal cost below average cost, you're not earning enough to cover your fixed costs. But if it's crossing marginal cost above your variable cost, you are earning enough to be able to like pay your workers and pay for ingredients or something. So I like telling the example of like a cookie factory, right? Or like a cookie store. So you're making cookies, your capital is going to be the storefront and the ovens and the refrigerator and everything. Your marginal cost is going to be the electricity and the boxes you're using, and then the wages for workers. All right, so if the price of cookies is greater than the price of like its ingredients and the labor necessary to make it, but not enough to be able to pay for rent and to be able to recoup the costs of like the refrigerator and ovens that you've got, you still want to produce, because I said the price is high enough to cover like the ingredients and the wages. However, you definitely want to exit that industry, right? Because you're paying and you're earning enough to be able to cover your variable costs. So it makes sense to keep producing because you're cutting into the huge fixed cost that you owe. If the price is below the shutdown point, then the firm will shut down immediately since it's not even covering its variable costs. That'd be a situation where in this cookie factory, you combine the ingredients to make cookies, and the price people are willing to pay for the cookies is less than you paid for the ingredients, or less than you have to pay to make it after thinking about the ingredients plus labor costs. This would be a situation like in our raspberry farm example, where the market price of raspberries is so low that you lose money harvesting it. Like the wage that you have to pay workers to harvest the raspberries makes the marginal cost of producing an additional raspberry so high that you can't recoup your variable costs. And so yeah, you'd shut down immediately. That'd be a situation where you just leave them on the bush. All right, so entry and exit decisions in the long run. Entry: when new firms enter the industry in response to increased industry profits, the idea is if there's positive economic profits, additional firms are going to want to enter the market. Exit: the long run process of reducing production in response to a sustained pattern of losses. All right, fine. So if there's economic losses in an industry, we expect firms are going to leave the industry, right? Long run equilibrium is where all firms earn zero economic profits, producing at the level where price equals marginal revenue equals marginal cost, and price equals average cost, right? Well, I mean, at least our marginal firms earning zero economic profits, but yeah, in the long run, we'd say economic profits are zero. Okay, so we can define a constant cost industry. So that's one where as demand increases, the cost of production for firms stays the same. An increasing cost industry: as demand increases, the cost of production for firms increases. And a decreasing cost industry: as demand increases, the cost of production for firms decreases. This might be like an economies of scale story. So demand increases, you ramp up output, and then average costs fall. All right, so here's the pictures. This is the constant cost industry. This is an increasing cost industry and a decreasing cost industry. And so what's happening here is we have this horizontal long-run supply. Here we have this like upward sloping long-run supply, and here we have this downward sloping long-run supply. The idea is in panel A, demand increases and supply increases as well by a proportional amount, right? So the supply increase is equal to the demand increase, so the equilibrium price stays the same as the quantity sold increases. In the increasing cost industry, demand increases and then supply increases as well, but supply increases less. And so as a result, the price rises. Or in this one, you have demand increasing, supply increases even more. And so you have a decreasing price. All right. In B, notice sellers were not able to increase supply as much as demand. Maybe there's scarce inputs or wages were rising, so the equilibrium price rises. In C, the sellers are easily increasing supply in response to the demand increase. Maybe there's new technology. We said economies of scale could cause a large increase in supply because of declining costs, and so the equilibrium price falls. Yeah. Right, so when profit maximizing firms in perfectly competitive markets combine with utility maximizing consumers, the resulting quantity of outputs of goods and services demonstrate both productive and allocative efficiency. Productive efficiency means producing without waste, so the choice is on the production possibilities frontier. Right, so the idea with productive efficiency means you're optimally allocating all productive inputs. You're producing somewhere on the production possibilities frontier, which means you're getting the most that you can possible with the resources available, and also is the assumption that the low-cost firm is the one doing the producing. In the long run, in a perfectly competitive market, the price in the market is equal to the minimum long-run average cost curve. Right. In other words, the firms produce and sell goods at the lowest possible average cost. Yeah, this is a consequence of this adjustment, this long-run dynamics is as the price is falling, as firms are in the market, it'll fall to the minimum long-run average cost, and then anybody with higher cost has to exit, is the idea. There's going to be this competitive pressure that enforces price getting down to minimum long-run average cost. Allocative efficiency means that among the points on the production possibilities frontier, the chosen point is socially preferred. So this is like the idea that the goods are going to consumers who are willing to pay the most for them. And so, in a competitive market, price equals marginal cost of production, right? When perfectly competitive firms follow the rule that profits are maximized by producing at the quantity where price equals marginal cost, they're ensuring social benefits they receive from producing a good are in line with the social cost of production. Well, that's because of the price part being representative of the willingness to pay of consumers. So the price you can think of as the marginal benefit, in this case, like to society, and you can think of this as the marginal cost to society. And so the competitive equilibrium is going to maximize total surplus in the sense of maximizing like total economic value in the market for everyone. And then, it amounts to like, different sorts of considerations or assumptions about how that surplus gets allocated. Perfect competition is a hypothetical benchmark, just as I said, right? It's going to be the kind of quintessential identical or optimal market structure in the sense of maximizing efficiency. Real-world markets include many issues that are assumed away in the model of perfect competition. Yeah, we said that. Pollution is an externality. Inventions of new technologies, okay. Poverty, government programs, discrimination in labor markets, buyers and sellers with imperfect and unclear information. This is asymmetric information. So in the microeconomics text, we'll talk about pollution, negative externalities. We'll talk about asymmetric information. These are all causes of market failure. Some of these other things we address in kind of one way or another. But, okay. So that's the end right here. we will come back to this in a future lecture. The next one is on monopoly. So I hope you enjoyed this, and I'll see you in the next one.